In our previous session, we have discussed the design stages and weight estimation of RC plane. Now we will start off with the RC wing design. The internal structures of most wings are made up of spars and stringers running spanwise and ribs and formers or bulkheads running chordwise, leading edge to trailing edge. The spars are the principal structural members of the wing. They support all distributed load as well as concentrated weights such as the fuselage, landing gear, and engines. The loads on the wing are the sum of aerodynamic lift and drag forces as well as concentrated and distributed weight of wing-mounted engines and structural elements. A concentrated load is a force applied at a single point on the beam or structure. It can be uniformly distributed, wherein the amount of forces is the same throughout the area to which it is applied, or non-uniform, meaning it is not evenly spread out. Distributed loads are spread across the whole region of an element, such as beam or slab. Ailerons located at the tip for roll. A flap is a high-lift device used to reduce the stalling speed of an aircraft wing at a given weight. Flaps are usually mounted on the wing trailing edge of a fixed-wing aircraft. Flaps are used to reduce the takeoff distance and landing distances. The skin, which is attached to the wing structure, carries part of the loads imposed during flight. It also transfers the stresses to the wing ribs. The ribs in turn transfer the load to the wing spar. Let us look in details now. Spars. Spars are the principal structural members of the wing. They correspond to the longerons of the fuselage. They run parallel to the lateral axis of the aircraft from the fuselage towards the tip of the wing and are usually attached to the fuselage by wing fittings, plain beams, or truss. Spars may be made of metal, wood, or composite materials depending on the design criteria of a specific aircraft. Ribs are the structural cross pieces that combine with spars and stringers to make up the framework of the wing. They usually extend from the wing leading edge to the rear spar or the trailing edge of the wing. The ribs give the wings its cambered shape and transmit the load from the skin and stringers to the spar. Similar ribs are also used in ailerons, elevators, rudders, and stabilizers. Wing ribs are usually manufactured from either wood or metal. Stringers, referred to as longerons, run longitudinally along the span, transfers aerodynamic load acting on skin to other frames. Stringers to make up the framework of the wing. Skin. Often the skin on the wing is designed to carry part of the flight and ground loads in combination with the spars and ribs. This is known as stressed skin design. The all-metal full cantilever wing section illustrated in the figure shows the construction of one such design. The lack of extra internal or external bracing requires that the skin share some more load. Moving on to the types of aircraft wing. The wing configuration of a fixed-wing aircraft, including both gliders and powered aeroplanes, is its arrangement of lifting and related surfaces. Tapered wing. Wing narrows towards the tip, structurally and aerodynamically more efficient than a constant chord wing and easier to make than an elliptical type. Trapezoidal, a tapered wing with straight leading and trailing edge, may be unswept or swept. Delta wing, triangular planform with sweep leading edge and straight trailing edge, offers the advantage of a swept wing with good structural efficiency and low frontal area. Disadvantages are the low wing loading and high wetted area needed to obtain aerodynamic stability. Swept back wing. This wing sweeps rearwards from the root to the tip. At transonic speed, swept wings have lower drag but can handle badly in and near stall and require high stiffness to avoid aeroelasticity at high speeds. Constant chord or rectangular wing, parallel leading and trailing edge, simplest to make and common where low cost is important. Swept forward wing, the wing angles forward from the root. Benefits are similar to backward sweep. Also, it avoids the small stall problems and has reduced tip losses, allowing a smaller wing but requires even greater stiffness. Types of aircraft wing position. Low wing, mounted near or below the bottom of the fuselage. Dihedral, the tips are higher than the root of the wing. High wing mounted on the upper fuselage when contrasted to the shoulder wing applies to a wing mounted on a projection, such as the cabin roof, above the top of the main fuselage. Mid-wing mounted approximately halfway up the fuselage. I hope you guys would have understood today's session. Let's move on to airfoil design and how it is linked to the wing in the next session. Thank you.